Have you ever wondered why cryptography is crucial in the realm of information security? Let's delve into this fascinating topic. Cryptography, in essence, is the art of writing or solving codes. However, in the context of information security, it takes on a far more significant role. It's the robust shield that safeguards our data, the ironclad lock that keeps intruders at bay, and the secret whisper that ensures only the intended ears hear our message. Imagine a world without cryptography. Your bank account details, personal messages, social media accounts, and even your favorite streaming service subscriptions would be wide open for anyone to access. It's a chilling thought, isn't it? That's precisely why cryptography is so vital. It prevents unauthorized access to our data. But the role of cryptography extends beyond just preventing unauthorized access. It also plays a crucial part in maintaining data integrity. In simpler terms, cryptography ensures that the data you send or receive remains unchanged during transit. Whether you're sending an email to your colleague or transferring funds online, you can rest assured that the content remains unaltered thanks to the magic of cryptography. Now, let's talk about confidentiality. This is where cryptography truly shines. By transforming readable data into an indecipherable jumble of characters, cryptography makes sure that your private data stays private. So the next time you're entering your credit card details online, remember that it's cryptography that keeps your information confidential. It's also worth noting that cryptography is not a one-size-fits-all solution. There are various cryptographic techniques, each with its strengths and weaknesses, and each designed to tackle different security challenges. Some are built to secure your emails, while others are designed to protect your online transactions. So, it's clear that cryptography plays a pivotal role in protecting our digital world. It's the silent guardian that works tirelessly in the background, ensuring that our digital lives remain secure and private. Stay tuned as we delve deeper into the fascinating world of cryptographic techniques in the next scene. But how do these cryptographic techniques really work, you ask? Well, let's break it down. Cryptography is like a secret language that only you and your friend understand, but instead of a secret handshake, you're using complex mathematics. First, we have encryption. Imagine you're writing a secret message. Encryption is the process of turning your message into a puzzle that only someone with the right tools can solve. The original message is called plaintext, and the puzzle is called ciphertext. Next, we have decryption. This is the process of solving the puzzle. You take the ciphertext and, using the right tools, turn it back into the original plaintext message. But what are these tools? They're known as keys. Think of keys as a decoder ring. They help you translate the ciphertext back into plaintext. But not all keys are created equal. There are two main types, symmetric and asymmetric. Symmetric cryptography is like a padlock. The same key is used to lock or encrypt and unlock or decrypt the message. It's simple and fast, but there's a problem. You have to find a safe way to give the key to the person who needs to unlock the message. If anyone else gets their hands on it, your secret is out. Now, asymmetric cryptography is like a mailbox. It has a public key that anyone can use to send you a message, and a private key that only you can use to open it. This solves the problem of safely sharing the key, but it's slower and more complex than symmetric cryptography. In a nutshell, that's cryptography. You take a message, turn it into a puzzle with a key, send it off, and then someone else uses a key to solve the puzzle and read the message. And all this happens behind the scenes every time you send an email, shop online, or log into your bank account. With these fundamental cryptographic techniques, we can start to see how our data gets secured. Now that we understand the basics, how exactly do we implement these cryptographic techniques? First and foremost, it's about selecting the right cryptographic libraries. These libraries are packages of code that developers can use to perform cryptographic operations without having to write the complex algorithms themselves. Libraries like OpenSSL, Crypto++, and Bouncy Castle are widely used and trusted throughout the industry. Before you dive in, it's essential to remember that cryptography isn't a one-size-fits-all solution. The type of cryptographic technique you choose will depend on your specific needs. For instance, symmetric encryption might be the best fit for data at rest, while asymmetric encryption could be more suitable for data in transit. Next, let's talk about keys, the secret codes that lock and unlock your encrypted data. The strength of these keys is paramount to your security. It's like the lock on your front door. The more complex the lock, the harder it is for someone to break in. So, always opt for strong, randomly generated keys that are long enough to withstand brute force attacks. Now, implementing cryptographic techniques isn't a set-it-and-forget-it deal. It's crucial to maintain regular updates and audits to ensure your cryptography remains effective. Just like you wouldn't ignore a rusty lock on your door, you shouldn't overlook outdated cryptographic algorithms or libraries. Regularly check for updates and patches to keep your systems secure. Also, consider conducting periodic security audits. These audits can help identify any potential weaknesses, allowing you to tighten your security measures before a breach occurs. Lastly, remember that implementing cryptography is about more than just technology. It's about fostering a culture of security within your organization. Make sure everyone understands the importance of cryptography and their role in maintaining it. Implementation might seem complex, but with the right tools and practices, it can be effectively managed. Remember, the goal is not perfection, but rather continuous improvement in the face of ever-evolving threats. So, what have we learned today about implementing cryptographic techniques in information security? Well, we've discovered that cryptography plays a pivotal role in protecting our digital world. It's the guardian of our online transactions, the shield for our sensitive data, and the sentinel of our privacy. We've delved into the basics of cryptographic techniques, from symmetric and asymmetric encryption to hash functions and digital signatures. These are the tools that give us the means to secure our information. We've also walked through the steps of implementing these techniques. It's not just about choosing the right methods, but also about maintaining and updating systems as threats evolve. Cryptography isn't a set-it-and-forget-it solution. It's an ongoing commitment to vigilance and adaptation. So, as we venture forth into the ever-changing landscape of information security, let's not forget what we've learned. Remember, in the world of information security, staying one step ahead is the key to safeguarding your data.